Hi friends, today we will speak about one equation. This is important because the topic is that matrix eigendecomposition. Eigendecomposition. I mean vectors, eigenvectors, and eigenvalues. How two things like matching, right? Matching, then it gives us like solution about matrix A, matrix B. So we know how our matrix generating, right? So today we will speak about that. So just I know convention, okay, about this idea. Anyway, through thought way, we will do together all the things. Maybe will be some discount, okay, but don't worry about that. We will pick all the good things about this way, so we know how to consist things there. So anyway, our topics involves a lot of good information and equation, and so with this chronology. In this chronology, we learn everything, okay? I just want to expression you like that. Anyway, now, what we are doing here. Have you seen there, like A, it is matrix, equals to, this is eigenvector, and this between two eigenvector, it is eigenvalue, right? And we have -1. So if you ask me, hey, how you can explain us what is this with some solving system, I will say you A equals to, then I will say eigenvector, it is, but it is original, original, original eigenvector time, and we will open again. We have lambdas, you can say lambdas, or we can call it like eigenvalues, okay? Don't worry about that. Lambdas meaning also eigenvalues, right? Like that. And eigenvalues, and we will say lambdas time, what? What do you think? Inverted eigenvector. How we can do that? Just think about that. This we will say inverted eigenvector, vector. This is equals to a matrix. We can say a matrix for here. Okay, matrix. But this here, so I mean lambdas, in this place we have it's diagonal matrices. Okay, we implementing there this thing, okay, this diagonal matrix. You know, diagonal matrix is looking like that. We can say 0 0 0, and just no, I think we can do like that, 1 0 0 0 and 0 1 0 0 and 0 0 1 0. It's like identity matrix or symmetric matrix, so it's symmetry. Okay, you can think like that. And when we multiply our A matrix, I don't know, A matrix can be like 1 2, and just think 1 minute, I will show you here. Just think it is like this and can be like this. All the time when you multiply 1 time 3 and 1 time 2 and something like that, it will give us identity matrix, right? Don't worry about that. It will be same solution, just will be some more zero for contain, okay, for contain it. Anyway, now our equation is that. Now I will about it. Now we will solve together. Okay. How we will start it, right? This is my books. Okay. Now I will use NumPy. I will say import NumPy as MP. I have to do it. We know equation, our working system. Also, I will say for here, it will be diag, okay? Diagonal matrix, so you know what I'm saying. Now, we can start. Now, what we will have to say, we will say A equals MP array, okay? And we are going to put there some matrix numbers, so scalar numbers. We will say 4, 2, n minus 5 and minus 3, right? Okay, this is our A matrix. Now, what is A matrix? It is that. Look. Okay, I will come down right now. Okay. Now, we will do things here. This lambdas, I told you, lambdas meaning eigenvalues, okay? Don't worry about that. When I wrote there lambdas meaning eigenvalues. And this is eigenvectors. When I write shortly just V, it is eigenvectors. And we will say NP, lineal, it's linear algebra, shortly. Then we will say A. So it will be Eigen. So Eigen, this is just for Eigen. We're representing it like that. Then we will put there our matrix. It will be I, okay? Then just do that, run it. Now, we can check our eigenvectors. Look at that. This is very nice. This is eigenvectors. Now we can think this two eigenvectors equals to one eigenvalues, but I will show it. Just don't worry about that, okay? So maybe I can show it you very easy like that. How we can do that? Lambdas, right? We can do that. Yes, just I want to show you. This 0 times something like that, this and this equals to 2, okay? So it's matching with 2. And this 0 something like that, and 0, 9, blah, blah, blah. It is minus 1, okay? This is that. And this is equals to A. Anyway, just don't think about that too much. No, I will go to show you what we have to do here. Now we find it. This is first step, okay? Now I will speak about other step. Now we have to invert it. We have to invert our eigenvector to like inverse eigenvector, okay? We will do like that, okay? Just don't think too much about that. Just it is like that eigenvector invert. And what we have to say NP dot linear algebra, and we have good function inverse. So inverse. Now it will be it will invert it our original eigenvector. So it is V. I told you. Now, okay, we can check what is our V, right? Look now I will delete this other one because it will mix it your mind. Lambdas, I will delete it. Okay. Yes. I can come down like that way. Yes. Look, this is our original eigenvector. It is our inverted eigenvector. It is same, but just we inverted it, right? Okay, we are now going to do something here. So now what we have to do, we will find. So also we will put diagonal. We will make diagonal matrix about lambda. Look, now our lambdas. I think lambdas, right? If I'm sure. But we can make a little big, okay? We have also Python function lambda. So, you know, it's like definition, def something, blah, blah, blah. We're doing def x and something, and we're doing. Anyway, I just put there uppercase for first word. Anyway, you can think like that. Lambda equals, we will say lambda equals mp dot linalc dot diac. This diac meaning, I told you, diac, 1 minute, I will put also here, lambdas. Diac meaning diagonal matrix. I told you, I showed you. The 0, 0, 0 something have there, and you know, this is like identity matrix. It will give same solution. Now we'll say lambda, lambda, big lambda, lambda. Now we can check it. It's diagonal matrix. 1 minute. What is problem there? I think we have some problem here. It's not in linear algebra, maybe, if I'm right. I don't know what the problem there. All right, it is okay. Now, have you seen we have same solution? Or you remember? Now I will ask you that. Look, lambda, lambda, right? Sorry, not that. Lambdas, lambdas. Eigenvector, its meaning. Thus, we have 0 and 0. Just think what we done here. It is same, guys. It is same, really same. It is 2 and minus 1. It is 2 and minus 1. Just we put there for some 0. So to make a diagonal matrix. So it will be identity matrix, right? Anyway, now you know better what I'm saying. Now last, what we have to do. Now our equation will start here. Now we will say, so we can confirm that together. We can say np dot product, np dot, and we have to put our eigenvector. Then eigenvector, then what we have to put here, we will say np dot again, because we have to multiply eigenvalue time inverted eigenvector, right? You know, I think I didn't forget it, right? So I will say lambda and inverted. That's very nice, very clean, I think. So work it. Oh, what is that? It is good. Have you seen our equation? It is crazy equation. Look, where is the equation? Where is it? 1 minute. All right, here. Just take it, and now I will come down. Look what we done here. I will show you again and again. Our equation is that, and look at that. We done it here. This is that. It is same thing, right? Now let's check our A matrix. Have you seen? For 2 minus 5, 3. This is our equation solved. And this is our original A matrix. Have you seen? All equation is here. Anyway, love you guys. I hope you understood how to working the matrix decomposition system. I think you understand what I'm doing with this equation. So it is just how we have to understand matrix, how generating an eigenvalues and eigenvectors, then volume about eigenvalues, eigenvectors, and eigenvalues. Just we have to understand these things, because the meaning of concatenate these two things, eigenvalues and eigenvectors, matching meaning, is very important for our improvement system. So about equation system, it is very important. Anyway, thank you so much. I hope you like that. Maybe later I can share with you some amazing equation with programming. Okay, love you guys. See you later.